Hello and welcome to tutorial 9 where we will be looking at a single objective solver, namely the Galapogus solver in Grasshopper. So this should be a quick one and hopefully an enjoyable one too. So what we're going to do first is jump in here and place underneath the parameters tab. We're going to place this thing that looks like a couple of cells. I think they look like eyes, but whatever. We're going to place the Galapogus component. So what this wants is fitness genes, i.e. it wants to be fed a number which it should optimize, either minimize or maximize. So we're going to make that the volume of material. Note that we can only feed one fitness gene here. And then the genomes are those variables which Galapogus can alter independent of one another, but it will be looking for trends. So what we're going to do is plug in genome to, well, I reckon let's have a look at 3 sliders. So let's look at the diameter of the hoop as one of them that it can change. And let's look at, we need to hold down Shift, as with anything we want to choose multiple entries for. Let's let it change the diameter of the base. And thirdly, let's allow Galapogus to choose the depth of the base. And obviously when we say it's choosing, it is choosing within the bounds that we have already set for it, for each of those. And everything that's happening we have orchestrated and designed ourselves as the intelligent designer. Right, now let's place in a Boolean here. And we're going to set this as true, describe this as true if there is an invalid solution. Right, and where is this coming from? This is coming from our heads-up display. We've got our logic here to tell us that if it's false, it means that there's a valid solution. If it's true, there is an invalid solution. Yep. Okay, hopefully that's clear. We're just transferring where that logic is displayed so we can see it clearly with our script here. Let's go to mass addition. And here what we're looking for is the volume of material. So if we go back up to where we found the weight of each of our components as the input, find the weight of each of the components. We've got it here in newtons. Well, we can do it as a volume in meters cubed. Largely the same. We're just not applying the density of the material. Okay, so that's the volume of the material. We're going to add a stream filter. So that information will pass through, or this information will pass through a null. And the logic behind this is going to be our whether or not we have a valid solution. So if we've got a valid solution, then there'll be a false, and therefore the mass, or the volume of material will be allowed to pass through. However, if we have an invalid solution, this Boolean will be true, and we will be passing through null into Galapogus. But first we need to place a number container. We can't attach Galapogus to a panel, but it is nice to be able to see that information here. And actually we could, if we wanted to, we could add that information to the heads-up display and see that in the Rhino viewport. That might be something nice to see as we're running the solver. I'm not going to do that now. I am going to label this though volume of material. Great. Okay, so that's our first result. No result if solution is invalid. The reason we're doing this is we do not want Galapogus to take account of any solution that is not possible. There we go. Right, to demonstrate that this really is happening and that we don't get any volume of material, not zero, but we get null when there is an invalid solution, let's make the diameter of the base nothing. And we have an invalid solution, which is massively unsafe and will fall over immediately. We have null. So Galapogus will not take account of null information when it's searching for an optimal solution. So let's put this back up again into a valid solution. It needs to be quite big, doesn't it, for that top diameter of ring. Right, here we are. Here is the moment of truth. If we double left click on the Galapogus component and we say, well, the fitness gene that we are looking for, we want to minimize that. We don't want to maximize it. We want to minimize the volume of material. We've given it the bounds within which it can work. And click on solvers. I like to see every solution in the Rhino viewport. This is slower, but it just is quite, I think it's quite interesting to see every solution being flicked through. And then we can start the solver. So you'll be able to see here we are flicking through lots of solutions. And we can see how safe or unsafe a lot of these are. And if I scroll over to what Galapogus is controlling, we can see the sliders are being moved around in order to find an optimal combination which reduces that volume of material. And before long we will see a graph being plotted and it will converge on the best solution, what Galapogus thinks is the best solution. So at this point I'm going to stop talking and speed up the video so that you can see this go a lot quicker. So we can see that we have reached a convergence here, something that is very close to the limit of the factor of safety we've set. We could actually, in fact, set the limit to something like 1.5 or 2, but that is what we've allowed Galapogus to converge on with the minimum amount of material and the set number of coats that we allowed it to have too. We actually did reach convergence quite early on there. We can come out this and see what the diameter is that Galapogus has decided for us. There we go. So that is a single objective solver. Very useful, very quick. Hope you enjoyed it. So in the next tutorial, we'll be looking at a multiple objective solver and why we might want that, why you might want to choose that.